Why and how are we conscious? This question has plagued philosophy of the mind since its inception, and for a long time, no one seemed to have a good answer. However, modern quantum theories of the mind have suggested that our consciousness arises from specific interactions in the quantum realm. The ubiquity of these quantum interactions means this assertion carries with it the implication that consciousness is all around us, and ultimately postulates a type of panpsychism. With panpsychism in this case being the idea that consciousness exists all around us, inhabiting everything in the world. One of the foremost philosophers dealing with panpsychism, and indeed consciousness in general, is David Chalmers. In this talk, I'm going to look at how Chalmers sets up a sort of logical viability test for theories of consciousness based off of what he sees as the most valid and foundational arguments of the currently competing mainstream theories. From there, I want to explain and analyze two theories of consciousness, one being the theory Chalmers himself lays out, as well as Penrose and Hameroff's orchestrated objective reduction theory. And then I'm going to try to determine if these theories can pass Chalmers' test. Now, on to constructing Chalmers' constitutive Russellian monism. The main two philosophical schools of thought competing for ideological superiority in the modern discussion of philosophy of the mind are the dualists and the materialists. The materialists posit that consciousness is fundamentally rooted somehow in the physical or biological realm, while dualists claim that consciousness should be thought of, and indeed is, separate from the body. Each of these groups makes a foundational exception to the other in what Chalmers refers to as the two-pronged problem of consciousness. The problem is two-pronged because for most theories in these two realms, to succeed against one argument or logical test is to fail against the other. Chalmers' goal is to make the two competing arguments find a Hegelian synthesis, that being the reconciling of two arguments that satisfies the stipulations of both arguments. So to quote Chalmers here, in my Hegelian argument, the thesis is materialism, the antithesis is dualism, and the synthesis is panpsychism. So he's going to try and reconcile these two theories and find a type of theory of consciousness that works and will work under both frameworks. So, to start off here, the dualistic half of the argument that Chalmers is trying to synthesize is the conceivability argument. So he sets up the logical proof as follows. Let me do that right here. So the argument is based on the idea that conceivability reveals the logical possibility. This means that if an idea is conceivable, then it is therefore logical. From there, if an idea is logical, dualists could argue that the idea is metaphysically possible, which is enough of a foundation to argue towards a dualistic conception of the mind. The classical example of this is the thought experiment of a mind outside of the brain. Since you can close your eyes and conceive of your consciousness as detached from your physical body, it is therefore metaphysically possible that your consciousness could also exist separate from your body. This metaphysical argument is then leveled at materialism as proof that the theory is overlooking a possible foundational fact of the universe. There are, of course, many exceptions to the conceivability argument. Chalmers observes that many materialists think the conceivability argument against materialism and for dualism is countered by the causal argument against dualism for materialism. So this argument is as follows. Phenomenal properties are causally relevant to physical events. Furthermore, every physical event has a full causal explanation in physical terms. Third, if every event has a full causal explanation in physical terms, every causal property relevant to the physical itself is also grounded in physical properties. And fourth, if phenomenal properties are grounded in physical properties, materialism is true. This argument is founded on the belief that the mind is not simply an epiphenomena. Epiphenomena arise from the world but don't have any effect on it. So, it would be the idea that your mind is completely distinct from the physical world. So Chalmers does not completely reject epiphenomenalism, but states that epiphenomenalism is at least inelegant and requires special coincidences between conscious experiences and macro physical events that seem to reflect them. So this being the fact that I can think of moving my arm and then move my arm. Thought is conscious experience, and that macro-physical event is moving my arm. So it seems pretty weird that that would be happening in this pure coincidence, that I just happen to be thinking at the same time. So Chalmers believes that there's at least a prima facie argument against dualism. So now, given these contradictions, it seems a theory must provide the mind some ability to cause events, cause physical events, causal potency, if Chalmers is to be convinced. So the ultimate goal of this argument is to prove that anyone who would argue against a physical grounding for the mind is then also arguing for a purely epiphenomenal conception of consciousness, which is a much higher bar to meet, essentially, or makes the argument much less appealing. So while Chalmers seeks to engage with the extensive philosophical discourse regarding both arguments, the purpose of this talk is not to discuss the relative merits of either dualism or materialism, as Chalmers has already kind of done that. So as such, it's going to be accepted going forward that while each side would raise exceptions against the other's argument, neither has a logically sound grounding, and the ability to find a Hegelian synthesis, which is just kind of a synthesis, again, meeting both of those prongs between the two, should at least serve as a sort of litmus test for any theory of consciousness. So just to reiterate here, specifically, any theory looking for synthesis between these arguments is going to have to accomplish a few things. First, in order to overcome the causation argument, there has to be a clear chain of physical causation from some physical manifestation of the mind. So, for example, materialists could posit that our consciousness arises from the complex biological computation in our brain, and that the electrons and neurons firing in there, then you can kind of trace that out along our biological system to the eventual conscious action. Without some source of causality, consciousness is again relegated to the epiphenomenal realm, which Chalmers and I see as unconvincing. So the second prong here is that there must be some level of immutability to the theory. What I mean by that is that any theory of consciousness must place constraints on the consciousness as a means of justifying the inconceivability of something like the out-of-body mind example that we addressed earlier. An example of this would be the claim that our consciousness is placed into our body by an all-powerful God. This omnipotent God willed our consciousness into our body, and it seems inconceivable that we could, go against the will of that all-powerful God and move this consciousness out of our body. It's just an indomitable force. Generally, immutability must come from some overwhelming force or fact about the universe, as only a foundational fact can actually rule out conceivability. So in sum, Chalmers' test requires that 1, minds be causally potent in some way, and 2, that any relationship between consciousness and the physical world is immutable and impossible to conceive of otherwise. So now that Chalmers' goal, which is constructing a theory of consciousness that passes these specifications, has been established, we can move on to the synthesis he claims accomplishes that. And in doing so, hopefully we can further clarify this test Chalmers is describing as far as why exactly he chose this example for a theory of consciousness that passes his test. So to begin with, Chalmers sets up a consciousness as being of 2 different types. First is macro experience, which he defines as the sort of experience that human beings feel, and other macroscopic entities like animals would experience, and micro experience, which is the consciousness experienced by all entities that do not qualify as macroscopic. So that would be rocks, your computer, a glass. He makes the distinction that while we have good information regarding our macro experience, since we live it ourselves, micro experience is essentially unknown to us. Chalmers takes this differentiation between macro and micro experience and uses it to introduce the contrasting ideas of constituent and emergent panpsychism. So first off, under constitutive panpsychism, all macro experience is merely the combination and possible abstraction of micro experience. So that was a little unclear. To illustrate this, you can think of each micro experience as being an individual brushstroke, while macro experience is a painting. So we may experience a painting and see a painting, but that painting is actually comprised of individual brushstrokes. So that's kind of an example of how you can think of this constitutive panpsychism. On the other hand, emergent panpsychism basically postulates that micro-experience and macro-experience are completely unrelated. Right? It's not brushstrokes and painting. It's a painting and some dirt. It's just no relation to each other. So while Chalmers acknowledges that there's some merits of emergent panpsychism, he ultimately decides that it falls prey to the same arguments and problems that were presented against dualism, and instead focuses on constitutive panpsychism. So a specification should be made here that after he rejects emergent panpsychism, Chalmers is focused on a Russellian monism. Monism in this case referring to the fact that he views the physical and mental spaces as being one and the same. This Russellian monism, or more specifically, Russellian panpsychism, revolves around the idea that consciousness arises out of quiddities. This draws on the idea first postulated by Bertrand Russell in the 1927 book, The Analysis of Matter. Chalmers defines quiddities as fundamental categorical properties that play the fundamental roles specified in physics. So this is a pretty vague and intentionally so definition. So to translate this into a more workable definition, quiddities are essentially the underlying micro-phenomenal properties that work to produce some fundamental physical fact, like the mass of a particle. So quiddities are distinct from the roles that they play, which would be mass of the particle itself, or anything else about the particle, and instead represent the foundational cause of the property that they interact with. So that's kind of just confusing. Quiddities are pretty confusing, so don't worry if you don't understand these too well. It's not hugely important. Just know that they essentially cause some fundamental physical property. And while Chalmers goes more in depth into what quiddities are or were be, for purposes of this talk, what's important is that they're left intentionally vague and can simply be imagined as categorical stand-ins for the forces that they describe. This conception of Russellian panpsychism, Chalmers claims, addresses both the causation and conceivability arguments, with quiddities playing a dual role here. So first off, to get around the conceivability argument, he poses a variation of the zombie thought experiment, wherein a zombie is a person who behaves indistinguishably from a conscious person, while in fact being unconscious. While it may be possible to conceive of structural zombies, zombies that hold the physical structure fixed but do not maintain the quiddities, Chalmers claims that categorical zombies, which are ones which have intact quiddities, are inconceivable. This is essentially due to the categorical nature of quiddities and the very definition of quiddities themselves. So in this way, the quiddities actually provide the theory with that previously mentioned immutability. Since quiddities are defined by the very physical properties that they endow, they're defined by their physical causation, they're also causally potent. So this allows theory to fulfill both prongs of Chalmers' viability test. So, it passes the test, but at the same time, it only just barely passes. Right? The causation argument is strong in that consciousness would arise out of particles that are literally defined by their causal effects. However, his defense against conceivability is much weaker, as is the general specificity and feasibility of the theory. Since he essentially evades the conceivability argument by postulating that what gives rise to consciousness is an unknown and is therefore inconceivable. So while this technically passes his test, it also raises potential criticisms of using only this two-pronged approach to build a theory, since there's no question of scientific probability or likelihood or the level of restrictedness on the parameters in the theory, which is why this whole thing may be quite difficult to understand and quite confusing, since it's kind of intentionally set up to be that way. Anyways, moving on. Now that we have this problem introduced, and Chalmers has given us both his test and his example of theory that passes his test, we can move on to the familiar ground of quantum physics. So before I move on to detailing the specifics of orchestrated objective reduction, let's just go over a couple of basic concepts of quantum mechanics. While classical physics does a good job of describing things like the swing of a pendulum or how to build a bridge, as the system gets smaller, the conventional laws of physics, the classical laws of physics, start to break down. And when it comes to the smallest particles in the known universe, which are fractions of an atom on a subatomic scale, classical physics goes out the window. And quantum mechanics is a revised attempt to explain the quirky actions of the subatomic particles. Now, at its most foundational level, quantum mechanics revolves around state vectors. Now, state vectors are essentially a probability matrix of possible future states of a quantum system, and they have some unique properties that classical physics is unable to really account for. Because a foundational feature of state vectors is the probabilistic information that they carry, once they are observed or resolved, they're fundamentally altered. So the easiest way I found to imagine state vectors is that they're kind of like a lottery ticket. That ticket could either win the sweepstakes and be worth millions, or it could be a worthless piece of paper. Right? It's undetermined at the time that you buy it. So before the drawing, it follows that basic probability function, which is the chance of having the numbers on the ticket be drawn versus the chance of them not being drawn. However, once the numbers are drawn, that ticket is defined, right? It's either a winning ticket or it's a losing ticket. There is no more question of whether or not this ticket is a winner. So that is essentially how state vectors work. They are the pre-draw lottery ticket, and there's a certain possibility that when they're observed, and it represents the draw, they'll be in a certain state, either be a winner or a loser. So this means that state vectors have certain features that cannot exist in classical physics, namely that they cannot be read or transferred or reduced, as to perform any of those functions would require resolving the unknowns inherent to the state vector. And those unknowns are, again, an essential property of that state vector. So another way to visualize this, since state vectors are pretty tricky and are also very essential to know, another way to visualize a state vector is as a Galton board. So a Galton board is just a descending set of pegs and lanes. Now when a ball is dropped at the top of the Galton board, it falls and it bounces between the lanes. And you can see that probability distribution that forms as the balls kind of follow a standard bell curve. The metal balls that drop along a specific probability distribution, like on this Galton board, would each represent possible outcomes for the quantum state. However, until that ball is dropped, goes down and its landing is observed, its landing location is unknown. I don't know where this ball is going to fall. So I can guess, based off of where these other balls fall, what is the probability it's going to go to each individual slot. But until I drop the ball, I have no idea. So this unknown ball is essentially the specific particle in that is being represented by a quantum state, right? So when you observe it, that's dropping the ball, and you can see what goes. Up until then, the ball is undropped, and it fundamentally changes where it is once you observe it. So that's state vectors. And now the second concept I will touch on briefly is quantum entanglement. The understanding of quantum entanglement necessary for this presentation should be pretty simple, so don't be too worried. Quantum entanglement is the irreversible connection or entanglement of two quantum systems or state vectors. That's it. The easiest example of quantum entanglement is the photon split experiment. Essentially, photons have something called a spin. Now, this spin is not literal, but it can be visualized as such. The spin of a photon is unknown and for practical purposes undecided until we measure it. So in a photon split experiment, a laser beam, which is just a concentrated beam of photons, is shot into a set of crystals. Now, these crystals have an equal chance of spinning a photon left or spinning a photon right. Now, when you send in two photons to the crystal at the same time, and they acquire a spin, those spins are going to be in opposite directions. And this is due to the conservation of angular momentum. So just no energy can be created or destroyed. So if you have something going this way, there has to be something going this way, since you can't just create energy. Now, the relationship between these two photons is an illustration of entanglement. Either of these photons is resolved, and someone observes it and reduces that quantum state, something spooky happens. So as soon as one of those photons is measured, the other photon will snap in place instantly to maintain that conservation of angular momentum. So both of these are unknowns, and as soon as you resolve one unknown, you instantly resolve the other unknown, regardless of the space, time, or distance between them. And this seems to break every conventional law of physics. It breaks the speed of light. It breaks, it's called spooky action at distance for a reason. And it's super weird. So the mechanisms that underlie the specifics of quantum entanglements, how these reductions can happen over unspecified amounts of space-time is unclear to us, but all we know is that quantum entanglement essentially links irreducibly two quantum states and links them permanently. you can no longer go back. It makes a new state vector. So in addition to that, resolving any one of those state vectors in the new superposition of state vectors will further reduce all other state vectors. Now, one last piece of information that is relevant to this presentation is the specific conception of state vectors held by Penrose and Hameroff. While the existence of state vectors and entanglement is experimentally proven and almost universally accepted amongst quantum physicists, there's some disagreement regarding how accurate our representations of these structures actually are. For example, many quantum physicists would pose that the spin of a particle is never truly undetermined. We simply can't accurately measure how it's spinning at any given point. And when we do measure it, we actually alter that spin ourselves. So in this way, the indeterminacy would exist solely for the observer. Now, Penrose and Hameroff, and indeed many other physicists, take a very different approach to explaining quantum uncertainty, which is superposition. So a quantum particle in superposition literally inhabits every possible positional outcome of that particle simultaneously. So to help visualize this, take a look at the electron cloud figure. A particle in superposition would exist not in any single one of those probable locations around the nucleus, but rather it would exist at every dot at the same time. And when it's reduced to a single objective position, all but one of those dots disappear and leave only that single objective reduction, which is the final actualized position of the electron or whatever subatomic particle. Now, the reason this idea of superposition is philosophically relevant to this theory is because it allows for distinct causation within a quantum system. Without superposition, state vectors represent simply our ineptitude at measurement. But with superposition, they represent a truly fundamentally undetermined event and allow us and offer insights into the fundamental functioning of the universe. Now, with quantum mechanics crash course under your belt, let's move on to the orchestrated objective reduction theory. The orchestrated objective reduction theory, first presented by Penrose and Hameroff in their 1998 paper, Quantum Computation in Brain Microtubules, is a theory of consciousness which revolves around the idea that the objective reduction of quantum states is itself a moment of conscious experience. That is to say, when someone observes a state vector, and that state vector snaps into position, it's either a 1 or a 0, that is a moment of conscious experience. So the stipulation that consciousness arises out of the objective reduction of quantum space supports the panpsychist view that the dynamic creation and reduction of quantum states instantaneously throughout the universe is in fact the instantaneous and fleeting creation of micro-consciousnesses. So they posit that our cohesive human or animal consciousnesses are facilitated by structures in our brains called microtubules that allow these quantum systems to increase in complexity and function as a sort of quantum computer that would be performing operations that are then relayed out through our existing brain biology to our other physical structures. So this cohesiveness is achieved through the continual realization and reproduction of quantum superpositions at an extremely high rate, upwards of 40 megahertz. So that means that, essentially to translate this all, your consciousness is formed by the constant creation and reduction of these individual superpositions, as facilitated by the microtubule. So while this theory may sound like a long shot, many of the principles it incorporates are pretty standard for quantum theories of consciousness. And to keep this presentation focused, let me touch only briefly on proving the foundational legitimacy of underlying scientific principles and proofs. First, there's a question of whether microtubules in the brain could truly facilitate this process. Quantum entanglement and manipulation, if only to scale, is an extremely delicate process, and scientists have previously postulated the brain is too warm, wet, and noisy to maintain a quantum system. However, recent research has backed up the claims regarding microtubules in a few important ways. First is a 2018 study confirming the existence of quantum vibrations, which is essentially quantum activity, in microtubules. So the physical structure of the microtubules themselves apparently insulates them enough from the ambient energy noise of the brain that they can enable and maintain these vibrations. So that kind of proves that quantum activity in the brain is possible. second study, also from 2018, looks at anesthesia, specifically xenon gas, a certain type of xenon gas, and how it interacts with the brain. Now, anesthesia is an especially useful tool in studying consciousness, as flicking the light switch of consciousness while leaving the brain functions unaffected allows for partial establishment of causation. So this study found through genetic and epigenetic testing that it actually, that this gas that was an anesthetic acted specifically on microtubules in the brain, as opposed to the assumed effect on synaptic connections. Furthermore, the study found that when a quantum spin is applied to the gas, so that it is chemically identical and should operate biologically identically, it's actually no longer effective as an anesthetic, despite all of those facts that it shouldn't. So this is kind of a big question mark and a big discovery, because this shows that there's something completely different going on here. So the further implications are twofold. The primary finding is that quantum consciousness or not, microtubules appear to play some important role in consciousness, and that's why this gas is acting on microtubules. The second finding suggests that, though the research is very preliminary, quantum activity could actually excite consciousness, enabling further quantum activity in the brain despite biological restraints. So with that background provided, we can now finally move on to our Hegelian synthesis and analysis. So, simple comparison between Russellian panpsychism and the orchestrated objective reduction theory reveals critical similarities and a couple points of contention. To start, both theories seem to support a constitutive theory of consciousness, as they both argue that consciousness arises from and is encapsulated by the microscale, which would be either quantities or state vectors, and quantum superpositions. So where they seem to differ the most is in the distinction between quantities and the quantum systems. And that difference is pretty tricky. So while quantities and quantum systems share some qualities, right, they're both currently unobservable in their natural state, they occupy fundamentally different spaces in physics. Quantities are, at present, an unknown. While there's no good proof against their existence, there's also no proof in favor of it. And while the phenomena that they produce is useful to us in physics, whatever quantities are is basically irrelevant to our current conception of how they practically work. Quantum particles and systems, on the other hand, are experimentally proven. We have enough of an understanding of quantum systems that not only can we postulate about their mechanics, but we can put them into use in building quantum computers. So turning to Chalmers' two-pronged causation and immutability test to orchestrated objective reaction, it seems that the theory largely holds up. In addressing the first problem, which is causation, the previously mentioned stipulation of quantum superposition, which is that all of the particles exist simultaneously in each position, that should make more sense now, as that's needed to establish causal relevance. Since quantum systems can exist in superposition, an objective reduction of the system would imply a literal physical change in the location of a particle, and that allows it to pass the causation test. Right, the change in a particle can be extrapolated outwards down the chain of events to build towards higher order actions. Moving on to the second problem, we find that quantum state vectors provide the perfect example of immutability. Because state vectors can carry probabilistic information about a superposition, it is quite literally impossible to recreate or clone a specific state vector, since the measurement of a state vector causes collapse. Therefore, it is inconceivable that one could transfer or recreate a state vector in any way except for just as it is. And this provides orchestrated objective reduction with the foundation of immutability it needs to pass the second point. So now, having succeeded against Chalmers' prongs, orchestrated objective reduction seems a great candidate for his Hegelian synthesis, in that it accomplishes the causation and immutability easily, and furthermore, it's got a solid backing of scientific proof to provide further feasibility. There's even the possibility that despite differences in the theories, orchestrated objective reduction and Russellian panpsychism can actually be completely reconciled. And quantities, if they exist, are an essential underlying aspect of quantum superpositions. Perhaps there's even some quiddity that defines how a superposition was created and maintained. Additionally, while orchestrated objective reduction postulates that consciousness arises solely out of the reduction of a quantum superposition, neither the evidence nor the logic in support of the theory necessitates that's the only factor. It's entirely possible that there's other microparticles at play. That's especially if some unknown or undetectable quantity of liquidity. Moving on, while Hameroff and Penrose describe the ambient reduction of superpositions as a type of bubbling to the surface of consciousness, and that there's ambient construction of a superposition, and that's an individual moment of consciousness that is then broken down and blinks out of existence. They don't make any distinction between that experience of consciousness and the instantaneous conscious experience of a human. In fact, they describe this bubbling as moments of experience blinking instantaneously into and out of existence, the same way it would for a human. Now, what this entails that under orchestrated objective reduction, there is no fundamental difference between macro and micro experience. It is all the same. So rather, our experience of each moment is molded by our biological system and presented in such a way that it seems contiguous, specifically through the constant high-frequency construction and reduction. Now, for me, this raises the question, is a theory truly constitutive if there's no higher order of consciousness? If human experience is produced in an identical manner to that of rock, I don't think it's possible for those conscious experiences to diverge in such a way that we would consider them substantively different. If that were the case, I think it could be similarly said that since each person's brain constructs a quantum superposition according to its own parameters, consciousness is entirely bespoke to everybody, and there is no underlying character of human consciousness. So these are a couple of logical failings or logical facts that need to be addressed to kind of flesh out the work of our theory more, at least in my view. Now, of course, our lack of knowledge of the specific mechanisms that could translate a quantum reduction into a moment of experience means it's possible that human consciousness possesses features within its superposition that somehow differentiate it from other forms of consciousness. Maybe there's extra particles in the superposition or a very specific arrangement. Now, while Hameroff and Penrose haven't posited that any such difference exists, I don't know if it's necessarily impossible or even implausible. Now, another possibility is that the unique aspects of continuous human consciousness that differentiate it from the momentary consciousness of something like a rock, specifically the biological origin and constant frequency of revision. For example, there could be latent quantum information in the brain that's incorporated into each superposition when it's refreshed. So, there could be as you break down a superposition, there are artifacts that are used in the construction of the next superposition, giving us type of consistency over time that we wouldn't see in instantaneous moments of consciousness. This would also suggest that quantum particles could act as a type of fuel for consciousness, and that there might be a certain threshold needed to produce a macro experience. So, while many theories stipulate different orders of consciousness, as Chalmers points out, they often fall prey to the causation argument. However, the chain of causation would still be pretty clear under the conception of orchestrated OR, perhaps even more so than the original theory, so I think this actually still holds up. And in conclusion, while there's still much unknown regarding the science behind Chalmers' Russellian monism and Hameroff and Penrose's orchestrated objective reduction theories, logically, they both seem to hold. Both theories escape the prongs against dualism and materialism while also providing a compelling and plausible account of the biological and physical mechanisms behind consciousness. Orchestrated objective reduction seems more grounded in the current scientific conception of quantum mechanics, but neither theory stretches too far past the plausible. The biggest standing question seems to be one of the qualitative nature, and is there a difference between the human experience of consciousness and that of, say, a rock? So while these theories describe the origin of consciousness, they also cast little light on the true nature of conscious experience. We can only hope that with further scientific discovery, it becomes possible to put these theories not just to a logical test, but to a scientific one as well.